Alright, here we go with our next type of factoring, my fantabulous geometry students. We just did perfect squares. Now we're going to look at what happens in this case where I've now got a value for a. Remember my quadratic formula, ax plus bx plus c. These could be negative values as well. But now I've got an a value which we haven't looked at yet. Well, fortunately, with this type of factoring, sometimes this a value is a factor of each one of my values b and c. So, for example, in this first one, you notice that all numbers a, b, and c are even. So I could divide all three of those numbers by 2. Well, when I divide a by 2, it gives me a 1 in front of my x, which is what I like to factor with. So I'm going to undistribute this 2. I'm going to pull it out of the whole thing by dividing everything by 2. So I'm going to have 2 times whatever's left over. Okay? So if I divide x squared by 2, I'm left with just x squared. If I divide 14x by 2, I'm left with 7x. And if I divide 20 by 2, I'm left with 10. So now this looks like something I could probably factor. I place my x values. Both my signs are positive values, so I know that they are both going to be positive. I'm looking for a number that multiplies or has a product of 10 and a sum of 7. A product of 10 and a sum of 7. So I look at my factors of 10, 1 and 10, 2 and 5, and it looks to me like that won't work. 2 and 5 has a product of 10, and if I add 2 and 5, it has a sum of 7. So it looks to me like those two numbers work. 2 and 5. And I can't forget my leftover 2. Now, how do I check my value? Well, I'm going to go through and I'm going to refoil, but I have this extra value out here to deal with, so I just need to make sure I follow the rules of PEMDAS, parentheses, exponent, multiplication, addition, subtraction. So I have 2 times x plus 2 times quantity x plus 5. It does not matter which order I do this in. So for the first example, let's just multiply and do my FOIL first. X times x are my first terms, gives me x squared. My outer term, x and 5, give me 5x. My inner terms, 2 and x. 2 times x is 2x. And then my last terms, 2 times 5, gives me 10. Maintain my parentheses around that. Now I can combine my like terms. When I combine my like terms, it leaves me with x squared plus 7x plus 10. So far, so good. I carry my 2 down, and when I multiply the 2, I distribute it by each one of these terms. I distribute the 2 because I undistributed it back here. I pulled a 2 out of each one of those terms. So I distribute it back in. 2 times x squared is 2x squared. 2 times 7x, 14x. And 2 times 10 is 20. So I look back up. I had my extra multiplication step in here. 2x squared plus 14x plus 20. 2x squared plus 14x plus 20. Looks like I did it correctly. Okay, let's look at example 2. I'm looking for a common factor in all 3 of my terms, 1, 2, 3. Looks like my common factor is not 2 because I have some odd numbers. But if I divide 20 by 5 and 20 by 25, I can do that. So it looks like my common factor in this case is 5. So I'm going to divide each term by 5, or I'm going to pull a 5 out of each term. I'm going to pull a 5 out of each term. So if I pull out of the 5 out of the first term, 5 divided by 5 is 1. Leaves me with 2x left over. 20 divided by 5 is a positive 4. leaves me with 4x left over. And negative 25 divided by 5 is a negative 5. So now I'm looking to be able to factor this term I have in my parentheses. So I'm looking for a value this time that multiplies to be negative 5, which means one must be positive and one must be negative, and has a difference of 4 units. So I look at my factors of 5. Pretty much my choice is 1 and 5. It multiplies if one is positive and one is negative to be negative 5, and they have a difference of 4 units. I know one has to be positive, one has to be negative. We can either start there, or what I like to do is go ahead and write my numbers down. 5 and 1. I look at this middle sign. Remember, I have a sign out here. It's positive, so this is my middle sign. I look at my middle sign. I know I want the sum, or those combined like terms, to be positive, so I'm going to give my larger number the positive sign. Carry my 5 from the outside. Now I'm going to do this slightly differently this time. This time I'm going to multiply the 5 by one of my quantities first. So I'm going to distribute my 5 into this quantity and then FOIL. It'll result in the same thing, but it's different than we did last time. So 5 times x, 5x, 5 times a negative 1 is negative 5. So I have this quantity on the left side. I'm left with x plus 5. Now let's FOIL what's left over. 5x times x is 5x squared. 5x times a positive 5 is positive 25x. Negative 5 times x, which is my inner terms, negative 5x. And my outer terms, negative 5 and 5 would give me negative 25. I'm almost there. I'm going to have to squeeze it in here. I'm going to write it right below this, and then I'll erase it. So I'm left with combining these like terms. 5x squared plus 20x minus 25. I look back up, and looks that's exactly what I started with. So I have the correct answer. Okay, so now we're going to look at example 3. I'm looking for a common factor in all 3 of my terms. Looks like my common factor is going to be 3. So I'm going to undistribute a 3 and then factor. If I undistribute the 3 from the first term, I'm left with just x squared. If I divide negative 18 by 3, I'm left with a 6x. And if I divide 27 by 3, I'm left with 9. So now I'm going to factor this term, all of these terms inside my parentheses. The last term is positive. The last sign is positive, which means I'm going to need 2 numbers that multiply to be positive. That's either plus and plus or negative and negative. But my second term, my second sign is negative. So I know that I'm going to need negative values. I'm looking for factors of 9 that will add to be 6, 1 and 9, 3 and 3. I think this is going to be it. So I put my 3's into my parentheses. Now let's go back and FOIL. Let's do it the same way we did last hour, the first way, which was x squared. My first terms, x squared times my outer terms, negative 3x, times my inner terms, negative 3 times x is a negative 3x again, and my last terms, which are negative 3 times negative 3 is a positive 9. Now I can distribute my 3 to all of my terms. 3 times x squared is 3x squared. 3 times negative 3x is a negative 9x. 3 times a negative 3x is a negative 9x again. 3 times 9 is positive 27. Now this time I saved my combining like terms until the very last step, which is here. So I have 3x squared, negative 9x plus negative 9x, or negative 9x minus 9x, which is the same thing, is going to give me a negative 18x, and my leftover 27, which is what I started with. Okay, last one. Now we're dealing with perfect square. Dealing with a perfect square. This process is the same. I'm looking for a common factor in these two terms, which I believe to be 4. So I'm going to undistribute a 4 out of each term. I'm left with 4x squared divided by 4 is just a single x squared, minus 16 divided by 4. Well, 4 times 4 is 16. Now I have a perfect square to factor. In my perfect squares, I know that one sign is positive and one sign is negative, and they have the same value. 2 squared is 4. So 2 squared is equal to 4. So this is the value that I place in my parentheses. Last step will be to redistribute FOIL and check my answer. So let's go ahead and distribute the 4 first this time and see what happens. 4 times x and 4 times 2. 4x plus 8, x minus 2. Now we'll FOIL. I have 4x squared for my first terms. My outer terms are a negative 8x. My inner terms are a positive 8x. And my last term, positive 8 times negative 2, is a negative 16. And it looks to me like negative 8 plus a positive 8, that is 0. I have 4x squared minus 16, which is exactly where I started. Okay, so now we're looking at where the a value goes into all the other pieces evenly, and I can undistribute a value. And then factor.